I would like to take a second to thank our sponsor for giving us the money to promote recycling.
What was the question?
The CANBOT works under a principle of it first needs to be appealing to use so people will use it, and then we made the drawings and the research to where it had the most efficient mechanical advantage to crush the cans at a not a rapid pace, but a efficient pace to where people actually would want to use it. And so we used an electric motor to a gearbox that rotates on a cam that strokes a lever all the way down between the can and the crushing end to fully crush the can, deliver the can to the hopper, and go back at a good pace so you can keep feeding cans in.
One of the major advantages to CNC manufacturing, like 3D printing or CNC router tables, is that you have the ability to draw it up in CAD first, which is making a 3D model of your part or assembly. This prototype was completely drawn up in CAD before we started manufacturing. That allows us to make sure that any materials we're going to use, like 3D printing filament or polycarbonate sheets, are optimized for efficiency, especially when we're talking about recycled parts. We don't want to be creating things that need to be recycled. That's part of solving the problem.
So my first prototype was manual, and so I did it by hand, and then I tried a pneumatic version, which is basically electric to pneumatic for the most efficiency, because you get more energy out of that pneumatic stroke than you did an electrical stroke. With mechanical advantage through the gear ratio and the amount of stroke that it takes for your cycle to go through. I just basically put a meter on there and see how much it was absorbing, and then got it down to change the mechanical advantage in the gearing and the length of the stroke to maximize the efficiency of crushing the can so that it actually stays economically feasible to crush the can and recycle them.
The population of Medical Lake is pretty small, with around 4,000 to 500 people. 4,000 to 5,000 people. We've got 4 schools, 2 elementary schools, and all of the kids go to those schools, or they choose to bus out to other more populated areas.
We are planning to bring the CANBOT to events like sporting events and community events. If we had multiple CANBOTs, they would be put around the other schools on trash cans and other places like that.
Most of our students either come from military backgrounds, or they're farm kids, or they come out of more rural parts of our area, not very much in town. The towns closest to Medical Lake are like Airway Heights or Cheney, and those have a slightly more developed population and like school district. Our recycling program in the area is not very defined, with a lot of neighborhoods not even choosing in to do the recycling program, and the ones that do don't have very many people that actually do it. Outside some of the houses, you only see mainly trash cans and not recycling cans. Our community's attitude with the recycling program, mainly a lot of people don't really trust it or don't believe in it, and usually stuff that gets recycled in small areas ends up in a landfill anyway, and it's a very minimal amount of recycled goods that do end up being recycled into other products.
Okay, so this is our first iteration of our CANBOT prototype. It's largely 3D printed and polycarbonate cut out on a CNC router table. Those are technologies that we have readily available to us, and it helps streamline the process for figuring out how we want the thing to actually work. What we have right now is an FRC competition motor on a series of gearboxes turning a crankshaft that gives us a really high torque output so that we can crush a large variety of sizes of cans. And then as the cam comes around, the piston extends out towards the back, and then when the piston comes back on its revolution cycle, then the can is able to fall down into the trash can that this is all mounted on top of, and and that allows us to contain the cans from the moment they're put into the crusher and keep them clean and people's hands off of them until we're ready to process them. Some of the major safety concerns we had when coming up with this design were, number one, keeping people's fingers out of the crushing mechanism. That can be a major pinch point. Alongside gearboxes and motors, those are all risk for electrical shock or heat or crushing of appendages, and that's less than ideal. So we made sure that anywhere there's any moving components, you can't touch it without removing covers, and that can only be done by people doing service on the machine. That way, we make sure that people aren't messing with things they shouldn't be messing with. We have a feed hopper that comes out of this side and sticks up quite a ways. It's at an angle so you can't reach your arm down inside. It also provides a buffer so you can load a number of cans at once. We also made sure that any moving components, like previously stated, will have their own dedicated covers over them. That not only helps keep things clean, but it also keeps people's hands out of stuff.